All right, today we're going to do solving two-step inequalities, and it's very similar to the two-step equations. It just has the inequality symbol in the middle, and then there's one more rule when you're dealing with negatives. Just a reminder that you should complete 3 more lessons in Imagine Math this week, and they're all about solving equations and solving inequalities. Only one of them is about inequalities, so hopefully you're all to that point. This is the same vocabulary that we talked about on Tuesday. So it has the coefficient, the variable, the constant, the inverse operations, and the reciprocal. You treat all of them the exact same as we did on Tuesday. This slide might be extremely helpful for those of you that are a little unfamiliar with inequalities. It has how you say each one and then how you graph each one. So most of your answers will have to be graphed on a number line, and depending on what type of symbol it is what type of circle it is, and then you shade based on the x value. So if x needs to be less than, then you would shade to the left. If x needs to be greater than, you would shade to the right. So we're going to practice a little bit of this. Okay, so just to show you the reason that one of the rules exists that we don't worry about when we're solving equations, if you multiply or divide by a negative number, your sign has to flip. And the reason that happens is just because that's how the math works. But instead of just having you memorize the rule, I'm going to go ahead and prove it. So negative 2 times 8 is negative 16, and 10 times negative 2 is negative 20. Well, if I'm going to graph those on a number line, then this technically would be 0, right? And this would be negative 16, and negative 20 would be over here. Well, originally, my symbol said 8 was less than 10. Well, is negative 16 less than negative 20? No. That is why our sign has to flip. So every time we multiply or divide by a negative number, our sign has to flip. Okay, so let's solve a few. I'm going to start out by showing you with algebra tiles how this works. So if we have 2x plus 1 is greater than 6, you treat it just like, okay, so now we're going to solve it just like we did the other day. We're going to start by subtracting 1 from both sides. What you do to one side, you have to do to the other. And this is going to cause 0 pairs. So these will cancel each other out, and this will cancel each other out. So now I'm left with 2x equals 5. Okay, so if I start to separate these into 2 equal groups, like we did the other day, this one could go with this one could come up with this one. Okay. Then I'm left with 1 that I'm just going to have to split in half to give half to each piece. Okay, so 1x is equal to 2.5. And if you want to plug that back in, 2 times 2.5 is 5, plus 1 is actually equal to 6. In this case, it can be anything that is greater than 2.5. Okay? All right, our next example is 4d plus 7 is less than or equal to 23. Okay? So we're going to solve it just like when we were solving an equation. We're going to start by trying to isolate the variable and get our constant to go to the other side. So I'm going to start by subtracting 7 to create a 0 pair here. 23 minus 7 is 16. Our sign stays the same. and bring down the 4d. Okay? Now we want to isolate the d, and if it's being multiplied by 4, we're going to do the opposite, which is division. So we're dividing by 4. So d is less than or equal to positive 4. Okay, we're going to go ahead and graph that down here. Sorry, it's kind of hard to see. We are going to draw a dot at positive 4, and it's going to be a closed circle because it has that or equal to. The closed circle means it could be equal to that value. And we're going to label that with a 4. And then d can be less than or equal to 4. So on a number line, less than goes to the left. So you would shade everything to the left. Something that is important to pay attention to is you want your variable to be on the left. That way it's easier to see how you would shade. Let's try another example. Negative 3x plus 17 is greater than 5. Okay, so we're going to start by getting rid of this constant right here. We're going to start by subtracting 17 from both sides. And then once we do that, we have negative 3x left on the left. Our sign stays the same. And then 5 minus 17 is negative 12. Okay. Then we're going to try to isolate the variable. So we're going to divide by negative 3 to get the x by itself. And if you remember, when we divide by a negative number, we always have to flip our sign. So then we're left with x is less than positive 4, because a negative divided by a negative makes a positive. So we're going to draw an open circle at 4, because it's not equal to, it does not have that line underneath the inequality symbol. And then again, it's less than, so we're going to shade to the left. All right, our next example is negative 7 is less than or equal to 5 minus 4a. So I'm going to start by getting that minus 4a by itself. So the inverse of positive 5 is negative 5, and that creates my 0 pair. What I do to one side, I have to do to the other. So negative 7 minus 5 is negative 12. Because we only subtracted, we don't have to flip our sign. And we're left with negative 4a is greater than or equal to negative 12. So now I'm trying to isolate the a, and I'm going to do that by dividing. So I'm going to divide by negative 4. Since I'm dividing by a negative number, that sign is going to flip. So now the open side is going to face the left, and the a is going to be by itself. Negative 12 divided by negative 4 is positive 3. I said earlier, when you're graphing, you're going to want your variable on the left because you always want to think in terms of that variable. So if you're able to, you can just say a is less than or equal to 3, and that will help you graph it correctly with a closed circle at 3, and then you shade to the left. I prefer to just flip my answer around, the sign and everything, so that I know that I shade left because this arrow is pointing left. But that's just personal preference. As long as you pay attention to the variable first and shade in the direction that it's explaining, you'll be fine. All right, I think I have 2 more examples. 2/3 x plus 7 is less than 29. So I'm going to start by getting rid of my constant using 0 pairs. The negative 7 cancels out the positive 7. 29 minus 7 is 22. 2/3 x is what's left on the left-hand side. Okay. I have this fraction as my coefficient, so in order to get it to go to the other side, I'm going to use the reciprocal. That was one of our vocabulary words at the beginning of the lesson. I'm going to flip that fraction, and what I do to one side, I do to the other. These end up equaling 1 because 3 times 2 is 6 and 2 times 3 is 6. 6 over 6 equals 1. So then I'm just left with x. My reciprocal was positive, so my sign does not flip. And then 22 times 3 is 66 divided by 2 is 33. So x is less than 33. It's going to be an open circle at 33. And since it's less than, we're going to shade to the left. So it's an open circle because it did not have the or equal to sign at the bottom. Okay. The last one is x divided by 4 minus 11 is greater than 1. I'm going to start by getting rid of that constant, the negative 11. The inverse of negative 11 is positive 11. So I'm going to add 11 to both sides. This creates a 0 pair. Then I'm left with x divided by 4 on the left is greater than 1. If x is being divided by 4, the inverse of that would be to multiply by 4. What I do to one side, I'm going to do to the other. So those are going to cancel each other out. X is going to be greater than 4. That's going to give me an open circle at 4. And since it's greater than, I'm going to shade to the right. Okay? Another way you could see this type of question asked is a work backwards situation. If they give you the x value and want you to figure out which one it works for, you would just plug it in all the situations and figure out which one's true. Okay? So you would have 2 minus negative 6 is less than negative 3. Well, 2 plus 6 is actually 8. Is that less than negative 3? No. 1 minus 2 times negative 6 is greater than 13. 2 times negative 6 is negative 12. Actually, negative 2 times negative 6 is positive 12. 1 plus 12 is 13. Is 13 greater than 13? No, it is not. Negative 3 minus 5 times negative 6 is less than negative 14. Okay, negative 5 times negative 6 is negative 30. Positive 30, sorry. Minus 3 is 27. Is 27 less than negative 14? No, it is not. Last one. Negative 5 minus 3x, oops, that's negative 6, times negative 6 is greater than 10. Negative 3 times negative 6 is positive 18. Minus 5 is positive 13. Is positive 13 greater than 10? Yes, it is. So that's the other way you could see the inequalities questions asked.